So, hello everyone, I'm glad to see you again on my channel. And today we'll try to check how we can use binary search. In general, binary search is an algorithm which helps us to faster search something in array. And in this exercise, we will see how we can implement this. So let's check this task, which is of level easy, and let's check the conditions. So you are given an array of integers, nums, which is sorted in ascending order, and an integer target. And we need to find the index of a number target in that array of nums. And if a number exists, we need to return its index. If a number does not exist, we need to return -1. And one important constraint here is that you must to implement an algorithm with time complexity O log n, which actually is a complexity for binary search. And below we have some examples. So we have an array of numbers, and we have target, which is equal to 5. That's the number which we want to find in this array using binary search. And the output will be 2 because it's index of element 5 in our array. And we have another example where we have another array, and in that case we wanna search element 4, but we don't have this element in our array, and that's why we return -1 index. So now let's answer to some questions. Let's check what kind of questions. So when can we apply binary search? What do we do at each step? And what pattern fits here? I actually recommend you to try to answer to all of these questions by yourself, because I really think that it helps you better understand the task. So try to do this. That's my recommendation. But let me answer to them right now. So when can we apply binary search? When the array is sorted, ascending or descending order, this allows us to repeatedly eliminate half of the search space. What do we do at each step? Check the middle element of the current range. If it equals the target, we return the index. If the target is smaller, search the left half. If the target is larger, search the right half. And what pattern fits here? Divide and conquer. So actually that's the pattern which binary search is using, because we can repeatedly divide the search space in half until the target is found or the range becomes empty. So I hope this helped you. Now let's check how we can implement this in code. So let's create our method. So it will be public and static, and we want to return an integer. Why integer? Because in the condition was mentioned that we want to return the index of element which we want to search, and if it exists we will return its index. If not, we will return -1, so we need an integer, int. And let's call this method find using binary search. Okay, perfect. And we will have two arguments here. So the first argument will be our array of integers, and the second argument will be our target, the element which we want to find in our array. Alright, so now the first thing which I want to do, I want to check if this array is not null, and if the length of this array is not equal to 0. Because if it is, we can return an -1 because it means that this array doesn't have any elements, so we don't need to start and to search something because it's empty where equals to null. So let's do this. Let's check if array is equal to null or array length is equal to 0. And if it is, if it's true, let's just return -1 without starting any process. Okay, cool. Now we need to have two variables, left and right, because we wanna find out in that range the middle element, and then to compare is it equal to our target, maybe it's greater, maybe it's less than our target, and so on. And knowing this, we will know where we can move further, in which half of the array we need to search our element. So in the left or in the right. So let's define these variables. Let's call one left. And initially it will start from the first element, from the first index 0, and the right, which will start from the last element. And for that we need to know length of our array -1. Okay, perfect. Now let's create a loop, because we need to iterate through our array, but we don't know how much time we will do this, because we from the start don't know how much time we will need to divide our array. And because of that, let's use while and put here a simple condition. So the condition is we want to iterate until left remains less or equal to the right. And if it's true, we will continue to iterate. Okay, perfect. Now let's find out the middle element in our array. So let's declare a variable which we will call mid, which is equal to, actually you can do something like this, left plus right divided by 2, and you will find the element, but this is not recommended when you use big integer values, because if left and right will be very big numbers, in that case it will cause some problems, because integer cannot hold infinite space for every size of any int number, so it will cause problems. In that case, it's much better and recommended to use this approach when you do something like that, left plus right minus left divide by 2. Okay, so it will give us the same result. And now let's make a check. So if element from the middle is equal to our target, in that case we can return the mid, which is index of middle element, which is equal to our target. So we have found our element. Okay, in case if it's not middle, we need to know in which half of this array we need to continue to search this element, and for that we can put another condition. So else if array from the middle, element from the middle, so let's write better like this, target, our element which we want to search, is greater than element from the middle. It means, because our array is sorted, it means that we need to search our target, our element, in the right side of this array. And for that, we will need to change the left pointer and to put here something like this, so middle plus 1. But in our case, if target is less than element from the middle, and because our array is sorted, it means that we need to search our element in the left side from the middle element, which means that we need to update our middle pointer, and here will be something like this, so middle minus 1. And in case if till that moment, which we iterate through our array, we haven't returned any index, we can return -1, because it means that so if we haven't returned any value here, it means that we haven't found target in our array, so we can return -1. And now let's check how does it work. So let's declare our main method, and inside this method let's call our search method. Here the first argument will be our array of integers. The elements should be sorted, and let's try to search element 4. Okay, and for element 4, index should be 0, 1, 2, 3. So let's check how does it work. Correct. So index is 3, 0, 1, 2, 3. Correct. Nice. So we have implemented our method, which uses binary search for searching. And now let's go back and try to analyze our solution. So the time complexity is O log n. At each iteration of a while loop, we divide the search space exactly in half. This makes the algorithm extremely fast, even for very large datasets. And the space complexity is O1 because we only use 3 variables, left, right, and mid, regardless of the size of the input array. Since we don't use recursion, which would consume stack memory, the memory usage remains constant. So in that case, I want you to pay more attention on the time complexity, because it's not linear. It's not ON when we, for example, use simple for, but it's much better. It's O log n complexity for searching. So that's the idea of that task, and it illustrates how binary search is working. So I hope it helped you better understand how this algorithm is working. So we will see in the next video.